Welcome to another scope teardown video. Of course I got a Hameg as well. So this is an HM203-6 20 megahertz dual channel. I heard this should actually be working. It was kind of on its way to the trash due to something with the attenuators. So I am going to look into that if that is true. So that means we are not going to expect any kabooms. What is... Okay, Cal, you need to... Okay. That was different. Okay, there is actually a little bit of click, not a click sound, but a little bit of click feeling. So that is the variable gain, how that works. Okay, DC, DC. Everything is super duper standard for an analog scope. And Hameg make actually quite good scopes, a really low price and very good performance to the cost. And this is why they're really, really famous. You will see a lot of them out there if you go and ask your friends and whatnot. So, all right, let's have a look at the back. So this is very, very classic. The name plate and the current settings for the fuse. So I guess the fuse will be inside somewhere. Maybe you just open here with those two screws. I haven't really understood how you handle the voltage selector. Maybe there is a tiny little hole here for a screwdriver. So it's set for 220. This I kind of like. So you can plug in your cable and then wind it up here, take it where you want, and then stick it in here so the wire is not gonna go lost. It's actually pretty cool. Let me try and play with this voltage selector. That was new. So it's actually the fuse that is the connector. Look at the 4 different pads here and the center pad. So this piece of plastic covers all the other outputs. So only one is connected of the 4 input or output to the fuse. So quite funny way to do this. I thought we have already seen them all, but this works quite well. All right, I think it's power on time. Okay, we're going to power this on. Nothing bad is gonna happen. 36 watts, 34 watts is what it uses. Oh, that's interesting. Okay, there's life. Whee, lots of brightness. Wow, this is powerful. And in good focus. Let me try and... No, it was the other one. Yeah. Ooh, that was a trigger level. Tip, tip, tip. But there isn't any visible dark lines or anything. So the CRT is in good shape so far. And trick seems to be working. Let's put some signals on and see how this... Ooh, okay. Yeah, okay, here we go. Okay, so those contacts are a little bit dodgy. It's already a lot better. Just use them and it will remove the corrosion, of course, or clean it up. Dual, let me see. Yeah, so this is the other one. Come on, Well, it's not that bad, is it? All right, I will play with this for half an hour and maybe I will get back. Oh, let me turn off the light. Or I should have maybe turned off some more. Let me see if I can get this. This is difficult to catch on the video, but this is a 10 millisecond pulse every second repeat, and it captures this exactly correctly. So this is the time base is correct, level is correct. So that is really perfect. Let me crank up the repeat time, because this is of course why it is a little bit annoying. Or we could just, so this is 20 times a second, and let's just do it much more stable, right? So this is our 10 milliseconds, and then of course it repeats again. So how about we change the pulse? Instead of being 10, let's go down to 1 millisecond, and then we try and play with the time base. Okay, so this is 2, 4, 6, 8, okay, 10. So this is also correct. And let's continue to do this with a square wave, right? So this was 1 millisecond. So 0.1 millisecond. And then we crank up the time base again. See? This is also correct. And then we can, of course, up the intensity. And yes, we can still focus this. And or I could just cheat and say repeat is 1 kilohertz, and then it gets a lot brighter. So that's pretty simple. All right, so let's change the pulse. Instead of 100 microseconds, let's change the pulse to 10 microseconds, and then change the time base again. Okay, so that was 10 microseconds. All right, let's go down to 1 microseconds. And then, ooh, I can't go any faster. So that was 0.5. So that means 500 nanoseconds for one division. So that's 2 divisions for 1 microsecond. Yes, that is correct. And it's actually still a square wave. And let me up the repeat. So that will give us a lot more brightness. This is pretty cool. Let me give me like a 100 kilohertz. Oops, that was not 100. 100 kilohertz, I said. Thank you. See? This is how bright it can be. Let's turn it down. We can just zoom out and see. So this is the pulse and the repeat. So yeah, maybe we should try and see how fast a square wave, like a small pulse, it can actually do. So that was 1 microsecond, and we are now running at the fastest time base. So that was 1. See, that was 500. Okay. Ooh, that was 100 nanoseconds, and we can still see the pulse. 100. Ooh, now the pulse is gone, right? So there's actually something here. That is 60 nanoseconds, the pulse. But of course you can't see the pulse. Yeah. Now you can see it, right? So I would say the smallest pulse you can see is 100 nanoseconds, but you can't really measure its time. So yeah, okay, this is 250 nanoseconds. Yeah, that's a half a division correctly. All right, I think we should measure the bandwidth. So that was, we need to put in a sign. All right, let's do the bandwidth test. I am now in the fastest time base, 500 nanoseconds a division. And this is 1 megahertz input. I have adjusted the level. So it's from 0 to 100%. Actually, I've been a little bit friendly, giving it a little bit too much, but let's just be a little bit friendly today, okay? So that was 1, and this is 2 megahertz, and then it'll go up to 10. Okay, so this is minus 3 dB, right? And this is, okay, 16 megahertz. And so it's not exactly 20 megahertz, but 16 is quite all right. Yeah, I wouldn't call this bad at all. Let's see what is inside, shall we? Teardown time. It was really easy to open this Hameg scope. I just took off the back plastic and then slide it off the entire casing. It is in one unit, easy. Look how well and optimized this design is. This can be assembled very, very fast. See how the frame is just some bent aluminium pieces. Super cheap. No screws in the main frame. The PCBs are really big and there aren't really a lot of cables. So this is how you manufacture stuff really cheap. And you use connectors. So it's click, done. Next, click, done. And so forth, right? Also, they're using, again, the long arms and switches exactly where they need to be. Super good construction for scopes and everything else. So you got the contacts exactly where you need the features. Power supplies. This is low voltage, low power. All this digital stuff or analog stuff or is really low power. Just some op amps and some super low power transistors. So of course all you need is like super tiny rectifiers. And again, note how well this is done. See, they bent the legs for components that are mounted on different things, so they will be able to move and not create cracks with time and stuff with thermal expansion. This is really the way to go. It's just done correct everywhere. Really beautiful single layer PCB. Super cheap to manufacture. But those are the deflection. So those wires, that will be deflection and high voltage. And that's of course the two different deflection amplifiers. Let's look at the top side of the scope. This will be the time base. And this one is doing all the different timings with resistors. And here we got some fine tuning. So this is actually a capacitor. You just bend and cut the wires. So this is trimming. Here is the two high voltages that goes to some 1000 volts capacitors and all those diodes in series. I think this is an optocoupler, right? And what else did I find? Yes, this is trace rotation. I've got some transistors to power this off. So this is a positive and a negative DC that goes through these two wires. They go around the tube, and it's just some windings around the tube, and that will just bend or rotate the entire image. So this is really a nice way to do that. Look at how they solved this. Really nice mechanical solutions for those switches. This is super smart and cheap way to do this. Let's see if I can get some light in here so you can see the different arms. Yeah, everything here is really fast to assemble, and again, just the cable up through some holes, stick it in, done. Cables, doot. Very, very fast. I love it. Oh yeah, the power. See, this goes all the way to the back, and of course the mains switch is all the way at the back, so there is no mains at all inside the unit. It's all on the back side, and the mains transformator is mounted on the back exactly as far as possible away from any magnetic sensitive parts, because a CRT is really sensitive to magnetic fields. So this is of course why you put the transformator as far to the back. The closer you get up here, it gets more and more crazy sensitive up here. But this is just the best way to put it. Look here at the back of the CRT. Again, a PCB, snap in, super fast and easy to manufacture. Of course they could win over everybody when it came to lowest possible manufacturing cost. And this tube is just pressed into this metal shield and held by those rubber grommets all the way around. So if you want to take out the tube, all you have to do is unscrew the entire front panel, and then you can press out the tube. Here on the two analog inputs, this will be the voltage attenuators and all the different capacitors for speed compensation. Look at that. A U440 dual matched JFETs. So that will be the first stage, ultra high input impedance. And then we go to a UA733CN. This is a 200 megahertz video amplifier. Again, a differential amplifier. And of course everything is differential, and this is how it's routed all the way to the deflection systems, because that is also differential. So yeah, that is basically what it consists of. Super duper beautiful. I really like the way they figured out how to manufacture this. Fast, simple, cheap. This is how you make money. Oh, there's some light in here. So it's just brilliant. Not all of the knobs are the usual screw types. See, those stick into a little PCB with some trimmers underneath here. So those you can just, those four you can just pull out like that. Easy. And behind those you will see a little washer. And I bet you just pull. How is this done? Because I don't see any screws. Maybe there's something secret underneath that one. Exactly my idea. You just pull this up and there is your secret. So now I've taken out all the screws. I would imagine that I could just carefully lift this up. There's a little bit, Okay, something here is stickity. What exactly is that? There's a wire. There's a wire. Ooh, look at that. That is brilliant. A front plate grounding. That is really, really smart. Come on, guys. They are thinking about everything. So now we're in, and those are the 4 trimmers that I talked about. Look at that kind of orientation to get a little bit more space for the connector. Isn't that just fantastic? Why isn't it rotated? I mean, why do you do that? And look again, the scope tube or the CRT front. I mean, the lines and the grid here is inside the CRT, and this is for best accuracy and readout. So the beam is actually, well, the white thing here is actually the phosphor, right? So when you put on the phosphor inside this piece of glass, you put on the red markings here first, and then you put on the white phosphor. And this is really, really the way to do it. In all the really cheap scopes, you have all the grids and stuff on the plastic. But of course, depending on the read angle, you'll get a different readout, right? Exactly as I thought. All you have to do now is just pull out the tube. And that is the trace rotation coil. Really, really beautiful tube. And here you see the first deflection. The last one is in here. I don't know if it's easy to see. And this scope is a little bit special. Here it is assembled. It's actually glued. Imagine that. So it's manufactured in 2 halves and glued together here, right? And all the connections for the entire CRT is on the back in the socket. So all I have to do is put it back together. See? This is all the beam shaping and focusing grids. And this little thing at the very, very back, that's the cathode ray emission thing. You can actually see the filament in there as well. Yeah, if you know where to look. Maybe I should try and clean this up a little bit. See, now it's nice and shiny. Ooh. Yeah. All right, that was fun.